All right, for 11.5, we're still doing probability, but now we're going to have a harder way to find that denominator, right? That counting principle with permutations and combinations. Remember, these two go together, right? Combinations is in its own little world. Okay, so example one, 6 jokes about books, by Groucho Marx, blah, 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 are written on one of 6 cards. So we have jokes on cards written by the following. The cards are placed in a hat and drawn out one at a time. What's the probability that a man's joke will be delivered first and a woman's joke delivered last? First of all, what is our sample space? How many total things are there? Well, we have 6 jokes on 6 cards, right? And we're choosing all 6. Order matters. We were very specific. These are people, each person's different, right? So we can get that denominator by 6, choose 6 with your permutation, or you could have done 6 times 5 times 4 times 3 times 2 times 1 with the counting principle and still got 720 total. Okay, so this is our S, or our sample space. It's our denominator. That's how many different ways there are to pick 6 of 6. That's a lot. Now for our event, what we're actually talking about, we have 6, 1, 2, 3, 4, 5, 6 things. And we want there to be a man's joke will be delivered first and a woman's last. How many men are there? Well, I think Phyllis is a woman, right? Female. The rest will just say their male names, right? So 1, 2, 3, 4, 5 males and 1 female. So I have 5 for the males and 1 for the female. So I got that done. That's that condition that it gave us. And then we look at what's left. Well, I have just left 1 man on the first and a female at the last. So how many people are left? If we take out those 2, we would have 4. 6 minus 2, there's 4 people left. And so it would go 4, then you'd lose 1, 3, 2, 1, so forth like that. So multiply those together and get 120. That's how many possibilities there are for this specific event, to start with a male, end with a female. So the probability of this event is going to be 120 out of 720, which you could reduce to like 0.6666 repeating, which would be 0.67, 0.2, something like that. This is one of my favorite problems. Powerball is a multi-state lottery played in most states. It is the first lottery game to randomly draw numbers from 2 different drums. The game is set up so that each player chooses 5 different numbers from 1 to 59 and a Powerball from 1 to 35. Twice per week, 5 white balls are drawn and blah, blah, blah. So let's start with the probability. Okay, so we have white balls, we have red balls. You have to deal with those separate. We've had this in our combination in our probability or in our counting principles, right? So let's look at the white balls first. There are a total of 59 white balls. How many of those 59 are we choosing? 5. It says 5 right here. So we are doing 59, choose 5. Why did I pick C? Because order doesn't matter. You just want them to pick your number, but it doesn't matter if I pick a 13 and then a 45 and then a 2. Like you just need to match them on your card, right? They're not necessarily going to come out of the machine in the order from least to greatest or anything. And man, it's already hard to win, but it would be really hard to win if you had to have this number and then they put all the balls back in and then this number, and then that would make the probability like even harder. So let's put this into our calculator. No real shortcut for this. I got 5,006,386. Okay, and then we look at the red one. That's our Powerball, and there are 35 of those. So 35, and you only choose 1. So 35 choose 1 is 35. So how many total ways are there? It's timesing these options together. That's how many different options there are. So we're going to times these two, and you're going to get 175,223,510. And this represents how many different tickets you could create, different possibilities for this lottery. Now, okay, then it says with one $2 Powerball ticket, so we only bought one ticket. So our probability of winning with one ticket is going to be one tick. Hopefully, you know what I mean. Is going to be 1 out of 175,223,510. Not very likely. This is actual Powerball. So I'm going to divide those real quick. 1 divided by 175,223,510. And oh my gosh, the probability is so small. Put it in scientific notation. So take 5.7 and move the decimal. Basically add 8 zeros in front. So 0.8057 is your probability. Now, if you want it in terms of a percent, add 2 more zeros. Oh, that's just awful. It basically rounds to 0% winning, but there's that slight chance, right? So we all buy a ticket when it's like that slight chance I might win. So when I was in college, someone did win at the time one of the biggest lottery things ever, and she was like on Oprah and all these things. I thought, man, she bought it at the gas station right by my house. So so bummed I didn't buy that ticket. Okay, so number 3, a club consists of 5 men and 7 women. 3 members are selected at random to attend a conference. Find the probability the selected group consists of 3 men. Okay, so there's a couple things. Again, we're looking overall, how many people are going, can we pick from for the conference? Well, that's 7 plus 5, which is 12. And we're picking 3. So our sample space is going to be 12, choose 3, no order, just picking 3. So that's 220. Okay. And if we were going to pick men, there are 5 choose 3 ways to pick a men, right? There are 5 total men. So there's 10 if you put that in your calculator. There's only 10 there for men. So the probability of 3 men is going to be the 10 out of 220. Or 1/22nd, whatever the decimal is. Okay, so you can see that sometimes you have to break it up differently. It becomes a little bit harder. Okay, so with these last couple, if you want to pause the video and try them and see if you can get them right, okay? And then start the video back up. This one says a box contains 25 transistors. Sorry, 6 are defective. If you pick 6 at random, what's the probability they're all defective? Okay, well, my sample space is going to be 25, choose 6. So choosing them all. Okay, and then defective, you would have to choose 6, which is just 1. So all defective is going to be 1 out of 177,100. Gosh, what's the probability of getting non-defective? How many are not defective? If there's 6 that are, then there's 19 not defective. So you could do like this, 19, choose 6, and that would be the like that we don't have any defective. Whatever that number is would be here over this. So you could have the probability of not defective might be a problem you have to. 7 performers, A, B, C, D, E, F, G, because I don't want to write names, are to appear at a fundraiser. The order of the performance is determined by random. Find the probability that D will perform first. So there's 7 total, okay? So, um, we could do this. First of all, sample space. There's 7 things, and we're choosing all 7, and order matters. 7, choose 7, because they are 7 performers. The order of the preference is determined by this, like it's specific on our order. So our denominator is 5,040. And for this one, I just think, well, the first spot's taken by D, and then I have 6 spots left. So it could be 6, 5, 4, 3, 2, 1, and it's 720. You could think of that as 6, choose 6. Um, I wonder if I think that would work. Let me double check real quick. Oops. I did it wrong twice. Yeah, this would be the only way I could think of to do it. Okay, question number 2, B. I was trying to think of like another way to show you, but I'm out. I could just think D is taken 6, 5, 4, 3, 2, 1. 6, choose 6. Yeah, because that first spot's taken. E will perform 6th and B will perform last. So now we have 2 spots that are specific. That guy has to be here. That guy has to be here. How many are left? 5, 4, 3, 2, 5, right? So we would have 5, 4, 3, 2, 1 left. And then the other 2 are specific. So that's going to give me 120. So it's 120 out of 5,040. What if I'm very specific? I want you to perform in this order. Then there's only one way to do that, in that order. Super specific. You have to be here. There's only one way. 1 times 1 times 1 times 1 times 1. 7 times will be 1. Okay, last one. F or G will perform first. So again, 7 slots. We have 2 options now for first place. How many options do we have left? Still 6 people, 5 people, 4 people, 3 people, 2 people, 1 people. So this is 1,440. So that is going to be 1,440 out of 5,040. So the probability gets a little bit bigger the less restrictive you are on that. The more restrictive, the less, the probability is less. Okay, that's what I have for this section.